Good morning, everyone. So this is a topic that I enjoy, and there's a lot of details that can be put into this topic, which is the learning about the different types of reactions. Now, what we're focusing on is going to be basically understanding what they are. Again, I'm going to give you an example for each of those, and then we're going to more specifically focus in on the signal replacement and redox reactions. So that might be in a separate video, but for now we're just going to focus on the simple part, which is what are the different types of reactions. Now, on this screen, you see that there are 5 different types of reactions, and just stating what they are, you have synthesis, decomposition, single replacement, double replacement, and combustion. And so now all 5 types of reactions, you're not going to be expected to know the details about every single one. But what I do want you to know is what is this type of reaction and how to identify that type of reaction. That is the goal for what I want you to do in terms of knowing the different types of reactions. Now, again, as we go into single replacement reactions, that reaction is going to be a little bit more involved into looking at what it is and how that's applied to reduction and oxidation. So all right, so let's get started here. So the first one is synthesis, and you can see on the right there that I've typed out what it is. So it's a reaction where 2 reactants will produce one product. Another way that you can be described is a combination. And so synthesis reactions themselves, they can involve many different things, but I'm just going to show you a couple examples to give you sort of an idea. So the first one is where we take nitrogen gas and we're going to react it with hydrogen gas. Now, when these 2 react together, they're going to form ammonia, which is NH3. All right, and this is the basis for how ammonia is actually produced. So the point here is that you take this A, which is the nitrogen, you're reacting it with B, and you're going to form the product C. You can call it AB, you can call it C, whatever you want, but either way, you're combining them together to make the new compound, in this case, the ammonia. All right, so that's typically the fashion that you see in terms of a synthesis reaction. So another one would be where we take liquid water, and what we do is we inject CO2 gas into it. Now, you see this is something that we take advantage of. You see it in seltzer water, which I know many people don't drink anymore, but you guys do drink the energy drinks like Bull and Red Bull, whatever else there is. There's many different drinks. And of course, I don't drink those. So Red Bull's about the only one I know. I think NOS is another one, but again, it doesn't matter. And then for those that like soft drinks like Pepsi, Coke, and so what they do is they inject a lot of CO2 into the water, and what that does is it forms H2CO3. Now, H2CO3 is also called carbonic acid, but again, that's just a little detail in that. But these 2 combine together to make the carbonic acid that you see there. Now, as soon as you open up, a whole different reaction takes place, and we'll talk about that next. So there's one more example that I want to show you. So let's take sodium solid, and we're going to have chlorine gas passed over top of it. So the way this would work is you'd have a solid block of sodium, and what would happen is that you would pass chlorine across the surface of it, and this chlorine gas would react with it, and a resulting product would be NaCl. And so again, this is your A, this is your B, and this forms AB, which is your product, NaCl. So that's it. So those are some examples of how to determine, if you're working with a synthesis reaction or not. Now, these are all synthesis reactions, and they all follow that pattern. A plus B yields AB. So if you look at your chemistry reference pages, you'll also see a set of reactions there, and it goes to the same process and talking about what the different synthesis reactions are, decomposition, etc. So I'd recommend you go to the helpful handouts and find that. All right, another one would be the decomposition reaction. So that's number 2. And decomposition reactions is where one reactant decomposes into multiple products. So in other words, you see the parentheses smelly there because when we think about decomposing, we think about things smelling, like animal tissue decomposing, just for example, or you go out in the woods. Right now is a perfect time. You can smell it. It's the smell of fall. You smell the leaves come off, and the leaves start to break down. Now, again, the NH3 can be reversed to form nitrogen gas plus hydrogen gas, and so you can see that it's the opposite way. You take the AB and you're breaking it down. It's decomposing into multiple compounds. Another one would be the H2CO3 breaking down to H2O plus CO2. All right, so that's another example of a decomposition reaction. One more example here, HNO3. Let's see here. Let's do H2SO3. All right, H2SO3 decomposes into water plus SO2. All right, so these are a couple of different examples here. So now these are similar to each other, but if you notice, what's happening is that the gas that comes off is based off of the polyatomic ion that you see here. In this case, carbonate and the sulfite both form carbon dioxide and sulfur dioxide. So, but the point here is that it goes from one compound to multiples. And I'll give you one more here. This one's a little bit more involved, but it's a good one. So this one is where you take the ammonium dichromate, so Cr2O7 is dichromate, and it forms nitrogen gas plus water plus Cr2O3. Now the neat thing about this is that this compound that you start with is a very, very bright orange, and then the resulting compound here is green. It's a dark green color. Now nitrogen is a gas and water is a gas, so this is a really, really hot reaction. It's exothermic, and so the nitrogen and water come off as gases, so you're left with just this dark green mass on the surface. Now I do believe I have this as a demo in the videos. If not, this will be an easy one to show y'all later on. So all right, but that's decomposition. Now, so again, we're just talking about the introduction to these different types of reactions. And so what we'll do here is we'll look at single replacement. And I'm not going to do much with this one, but I will discuss it since one reactant replaces another reactant. And the gist behind that is you take A and you're reacting it with a compound that's BC, and you're going to form AC plus B. So let me give you a couple examples here to follow up with that. So these are where you're going to use the activity series. But we're going to work on those in a separate video. So for now, I'm just going to give you an example here. So let's say that I have lithium reacting with NaCl. All right, the lithium will come in. It'll replace the Na, and you're going to form lithium chloride plus sodium solid. All these are solids, by the way. And so, or they could be, this one here could be a solution, possibly, and then this here would be a solution. But I don't know. I don't think lithium is going to respond very well in water as it is, because lithium is a highly reactive metal. So something that you guys can do is watch the Brainiac video on Brainiac alkali metals, that is a video I would recommend you watch on YouTube. And so you just search for it. It should come up pretty fast. And they'll actually go through the reactions. And so one of the reactions that you see is lithium reacting with water. I'm going to write it as HOH. And it forms lithium hydroxide plus hydrogen gas. And so when you form hydrogen gas in this situation, you'll see why I want you to watch this video. So I'm not going to say anything else. But so again, these are just a couple examples. So this has your A here, and this is your B, and then hydroxide your C. So A comes in here and replaces B to form the new products over here. So again, more details to come in the single replacement video. Double replacement is very similar to single, but in this case you have a doublet versus a single. So double replacement reactions is where you have AB plus CD. Now notice that you have one more part to the reactant, and you're going to form AD plus CB. Now your goal is not to predict the products. That's not, because we don't have time to do that, especially in this video. But our goal and our focus is to be able to identify the type of reaction. That's what I want us to achieve from this part. All right. So a good example would be NaCl reacting with AgNO3. Now, if you notice that you have the A, the B, the C, and the D, so the A goes in and it reacts with the D, and then the C reacts with the B. Now, I always write metal, non-metal, so that's why I put C to B. That way you know that C goes before B on the other side. So AD is going to be NaNO3 plus AgCl. So that would be an example of a double replacement reaction here. All right. So there are many of these. There are multiples of these types of reactions. So let me give you one that's a little bit more involved, but not much. So this is one where you have calcium chloride reacting with sodium phosphate. All right. And so the calcium is going to react with the phosphate, and then the sodium is going to react with the chlorine. So you're going to form the calcium phosphate, and then you'll have the NaCl as the remaining part. So again, the purpose here is not to get into the nitty-gritty details, but to basically look at something and be able to identify whether it's a single replacement, double replacement, or whatever one of those 5 types of reactions are. All right, now the last thing that we're going to talk about is combustion. And so it's where you have a reaction that takes place with oxygen. And the most common combustion reactions that we see is where we have organic compounds. And you saw this in previous balancing equations where you have C2H6 reacting with oxygen to produce CO2 plus H2O. You have C8H18 plus O2 yields CO2 plus H2O. These are all prime examples of combustion because each of those reactions have oxygen gas present, and that in turn produces the 2 products that you see. Other examples would be like the sodium plus the oxygen and the hydrogen plus oxygen. You see the oxygens there. That's going to create a combustion, and it produces the product. Now, the difference is for these two, you might look at this and say, well, this is a synthesis reaction. And yes, that's true that these are synthesis reactions, but they also can be classified as a combustion. But in our eyes, in our vision, with what I want you to see here, is that if you see these 2 reactions, your brain's going to click and it's going to say synthesis, and that's exactly what I want you to say. But if you did say combustion, you're not wrong, all right, because there is oxygen present, and that's a good example of where the different types of reactions sort of go back and forth within each